at the end, we might do a small discussion about how we'd like to progress with this initiative, and if there is enough momentum about that. So the workshop is organized as part of the WeDoWind user group, which has a relationship to IEA Task 43 data user group, which is not a public. And for that reason, through the platform WeDoWind, we've created a public user group that we discuss about SCADA events and alarms, and all this comes into place because of the discussion we have inside the IEA Task 43 user groups about the main problems we as professionals face in the wind energy sector when it comes to digitalization, analyzing data, and we've identified that analyzing SCADA data events and alarms is one of the main challenges we face in this sector. We've done a workshop in December, which gained some momentum, and during that workshop we've done a questionnaire at the end, and it was obvious. There were two things that were obvious from that workshop. One is that the majority of the people are not using any ready-made available tools. So most of the companies out there are developing our own tools, and they rely on creating also their own guidelines and standards to do this work. And the second thing that we've identified, that there was a number of people that were interested in spending more time investigating and doing more work on standardizing and integrating into this field. This is really why we've decided to do this workshop, and if there is momentum, then we might more of those, and to propose a way forward, and then discuss if people are interested in joining along and contributing in this. Yeah, that's all from me now. I'll pass over to Yuri, who do more of the technical part. Yep.
Aris Dimopoulos.
Okay, thank you, Aris, for the presentation. I got a couple emails while we are in the meeting that apparently the meeting doesn't allow people without Microsoft accounts to join. I changed the settings, so I hope it will work now, but we'll see. A brief introduction about the WeDoWind Data Users Group. There is Aris, who was just presenting. There is also Christian Johnson here from Kudo Software, me from ETH Zurich, and Des, who is trying to join, but he couldn't join because apparently there is some problem. So let me just very briefly go about a couple of slides that we already presented in the last workshop. The first one is the our current assessed state of the art, which most of the people seem to agree last time, that the IEC 61400-25 and -26, they made attempts to standardize SCADA protocols, but the adoption seems to be limited. And another thing that we've noticed in the industry, that there's like a variety of secondary SCADA systems in place that people put. And people develop their own processing SCADA alarms and event codes, and like software codes, as Aris just mentioned. Also, it was apparent from Mentimeter that most of the people develop their own solutions. There are a variety of additional services that people rely on to like process alarm codes for like benchmarking DTs, or they introduce their own systems. So many companies that do structural health monitoring, if they install their own sensors or their own systems, they completely introduce their own thing. From applicability side, many things like failure mode defects and criticality analysis, as I just mentioned, structural health monitoring, they all rely on information models that are made ad hoc, so made specifically for the purpose by different companies. So when companies develop their own software, they embark on giving structure to the data, giving structure to the code, writing down schemas, and sometimes they're not even aware, as we discussed recently with Christian and the teams, that often companies are not even aware that they're developing an information model, or that's what they're doing, and that there are actual like tools to keep on going with it. So we identified several potential improvement areas, and they kind of go from tiered, from easier to address, or like that should be addressed first before moving to the next one. And hopefully in today's meeting, we're going to start addressing the first level of these improvement areas. The first one was in terms of alarm event and representations, just like representing those alarms, like giving it structure, that we saw there are no common definitions and naming conventions for like what is an alarm, what is an event, what is a warning. Like there is no definition for these kind of things. And this is what we want to be addressing kind of today, start to be addressing today. The other two things that we pointed out or singled out were like there needs to be a better mapping between alarms, events, and warnings to physical turbine components. And there needs to be a consistent approach to accommodate sensors. So on the right here is like an example of a taxonomy of wind turbine components that was used by the Reliable Wind project. There are other systems to classify components of a wind turbine. For example, RDS PPE is one of that is quite adopted currently. And this is a fundamental thing that anyone who starts doing these kind of activities will have to contend with. Just recently, I was working on logic behind the failure modes, effects, and criticality analysis, and their model introduced different hierarchy levels, for example. So Reliable Wind taxonomy introduces things like system, subsystem, assembly, and subassembly, and then having like five hierarchy levels up to component. But the particular model I was working was having like system, assembly, device, and component or part, just 4. And then all the mapping becomes very difficult. So it becomes quite difficult to work with this kind of system. So it should be improved. From data management and alarm event processing side, we said that that would be nice to have some agreed alarm event warning data exchange format. Last time we said that we are quite agnostic about it. It can be like JSON plus JSON schema, or it can be like a SQL database for people to store, and then you have database schema, or like RDF and JSON LD formats. we are quite agnostic for it. Obviously, we have our own opinions, but so on the left here is an example of another thing I'm working on. It's a form that is generated directly from JSON schema that generates JSON type files and verifies them. This is for a different application and specifically for getting data about how the sensor is placed on a tower. But you can imagine that similar things can be done for other applications. So we will be talking a little bit about this first point on how to manage event data, but there are also other things that we pointed out last time, like the need for more consistent logging behaviors or like methodologies to isolate multiple consequential alarms, event root cause analysis, and so on, things that require logics and system engineering approach and things that are a bit more sophisticated. Obviously, the area is, as they say in military, right now it's a target-rich environment. No matter what we try to do, we'll have an area for improvement. The last thing we mentioned, that there is a need for open source tools to like explore, visualize, identify patterns and anomalies, and just in general to automate analysis. And I brought up this XCD comic that says that, like, in theory, when automation takes over, it saves you time. Unfortunately, in reality, often due to things like scope creep, it doesn't get to the point. So what we wanted to do today is actually to start this discussion so that it doesn't fall into this trap, and to define the application domain, the boundaries of application domain and to form this work group that would be working on starting to go through these potential improvement areas and to introduce this automation. So it would include, we would focus today on answering questions like what would be the purpose of automation, what will be intended like use case or task, what will be the needed granularity for this, so like what things should be modeled, and what are stakeholders involved and data sources that will be needed to do this. So as I said, the first improvement area was the alarm event in representations, and in here we saw that there is a need to start the discussion on and to start to have a work group that would work on the creation of an information model. We specifically we're looking into application and task ontologies, but like if people here and people who will be joining later on in the group, and we will also have a Mentimeter to like a little bit see where everyone stands. If there are people who are more comfortable with other modeling tools like UML, Unified Modeling Language, or JSON schemas, we can discuss that and see how the group can evolve. But as I said, the way we see it, it's the development of application and task ontology, specifically the ones from Semantic Web. Just a quick note on what ontology is. It's a formal, explicit specification of a shared conceptualization, which is kind of like a mouthful. But what basically what we mean when we say it, or when we say ontology, is that the formal means it's machine readable. I mean, it technically means that there is a rigorous mathematical and logical framework, but it also means that it is machine readable. Explicit means that everything, like all the entities and all the relationships are well defined. And another important aspect is that the conceptualization is shared, so that different stakeholders and the community in general like accepts this information model and uses it and reuses it. Otherwise, there is no point. Like we can continue on the trajectory that was going on before, where everyone develops their own ad hoc models, but we believe it's not very sustainable. It's going to be much better if not everyone is reinventing the wheel, and we can actually exchange data much seamlessly and not spend 90% or 80% of the time doing data pipelining and actually like working on algorithm or thinking about the analysis results. So this is like an example. It's not an ontology, it's just like an example of what I'm talking about. We identify concepts or types of entities. Some you can think of them as classes if people are people coming from object-oriented programming. And then even though it's a bit different from classes in programming, but still. And then there are relationships. So like requires actions related to component. So this is not an actual model, but I'm just to give an idea of what kind of things we would have to do to define the information model for or to represent things. And in terms of data management and log processing, we were thinking that while this ontology is being developed, it can be used as a basis for a knowledge graph. So it's getting populated with actual instances. And but again, as I said, we are not fixed on this. If people are more comfortable or saying that this kind of information can be better stored in any like relational database, so like PostgreSQL, it is fine. There are many techniques that allow mapping from an ontology to a SQL database schema where each entity roughly, and just like it's roughly, but each entity roughly corresponds to like a separate table. The properties of the node or the edge become the columns of the table, and then the relationships, that's kind of the problem with the relational databases, cannot be explicitly modeled in these kind of systems, but the modeler kind of like assumes that these relationships exist, but they're never explicitly modeled there, and the tables are connected by like external AD key elements. But just saying that's one of the possible options. So that is kind of like a brief overview of the state of the art of what we think we can be doing. And with that, I wanted to kick off the discussion on possible application domain for analyzing this type of data. So analyzing alarms and events, logs. We will have a Google spreadsheet. Let me see how many people we have. 12. So 3 groups, maybe 2. Yeah, maybe 3 groups of 4, which will be compiling, and the data in a spreadsheet will be focused on. So basically, each group can take on one application domain. So, for example, like I don't know, documentation or reliability analysis of gearboxes, basically what the information model is supposed to be helping with. And then for each of the application domains, there will be columns where we would want the work groups to like brainstorm on what would be the purpose of that application domain. So basically, it's listing competency questions. We already have collected quite a few competency questions, so you can take them from a list. You can add your own. Then another column will be, or another entry will be scope, which is like real world entities, like what things will actually like have to be modeled for this. The other one is linked data, so what kind of data needs to support later on or to populate with instances, this kind of information model, and then stakeholders that will be involved. It doesn't. I think there'll be extra columns in the like. Actually, let me open the.
I was thinking we have 5 minutes. Maybe we can, for people to,
Yeah,
if they want to ask questions here, and before we break in different rooms and start doing the work on this spreadsheet.
Let me just copy the link.
Okay.
Ganesh says I can support reliability analysis of gearboxes application domain. That's great. Again, it doesn't. I gave it as one of the examples. Whatever people are comfortable, because of just like the things that I know people might be interested in. It can be as narrow as like just gearboxes. It can be more broad. It can be or just like blades. I don't know. Or it can be more broad, just like reliability analysis in general. As I said, any questions before, like maybe questions on general on information models on or on the activity? So the competency question list is down here. I will create breakout groups, and we'll have 3. So since Ganesh said that he wants to do reliability analysis of intervention gearboxes, we can do exactly that. And that's, I guess, whatever group he will be in can do that. I think other groups can decide by vote. So let me try to create rooms. Just quick check. Any questions, or we proceed to breakout rooms?
Hey, this is Ganesh, and this is not the only session. We are working on the competency matrix, and it will be iterative process, right?
Sorry, I'm not sure I understood the question.
My question is, as we get into the breakout session, this is not the only breakout session where we will work together to build this Excel.
This is just for us to get like an idea and to see what application domain the group will focus before. We will see what people write down. We'll see which ones get more traction, and we will probably will have a vote later on in the community, because the thing with these kind of developments is that they cannot be done vertically. Like, we cannot address all possible application domains or possible use cases. I mean, ultimately they're infinite, but anyway, it's not good to take on many. It's much better to focus on a single one and then develop it horizontally. So develop a minimal information model, test it for if it is adequate for our task.
Okay.
But we will have a vote on that after the meeting. I think maybe on the WeDoWind community platform, we'll have like a poll to see which of the application domains we will take on. That is kind of the plan now. I already have some application domains seeded. You can use them as inspiration in the work groups, but this is kind of the idea.
Okay.
Also, there is no need to fill like the full Excel. I have like things like I think the most important things are this first 3 columns. Actually, first 2, and then the next 3 are good. And the last are for people who are very familiar with these kind of things too, if they can add some. Okay, I will pause the recording and pick it up later on for the Mentimeter and create the breakout rooms if there are no other questions.
So the assignment here is to just kind of brainstorm more ideas and try and fill out the first 3 columns for those ideas?
Yes.
Okay.
Perfect.
Exactly. And we were thinking we will allow 20 minutes for that, and then we will join 10 minutes before the end back here in the main room to close up and finalize the discussion and see how we progress from here.
Excellent.
So, okay, random. Ta-da. Okay, I think all the participants have been assigned. So, okay, and I joined this third one. Okay, I have to. Sorry.